Okay, so this is Alex Vantassel and Chance Beaver with our Digital 3 project. Okay, so ours is a Weight Watchers smart scale. So over here on the corner is a power button. It's a slider switch. You're going to slide the power switch on, and then the LCD is going to rotate upwards, and it's going to give you instructions on how to use it. So it'll say different categories of food you can select. So like 1 for chicken, 2 for beef, whatever. So you're gonna hit the type of food you want to do, and it'll update the display, the LCD. Keep it up. Tell you, what kind of, how you want it, how you're cooking it. So 1 for fried, 2 for grilled, whatever. You can have grilled chicken, and then you're gonna put the food on the scale over here, and it's gonna weigh it, either in grams or ounces on these 4 LED segments, depending on the slider switch you have over here, and it's gonna light up whether it's in grams or ounces. And it's also going to rack up the Weight Watchers points over here instead of having to reference a 7-page PDF spreadsheet. And it's going to give you instructions. When you're done, you're going to hit enter, and you can add more food to it. So after you're done with your chicken, you can add some mashed potatoes to it, and it'll keep separate grams and ounces for them, but it'll rack up the points so you can build a whole meal off of that. So now we're going to take a look at the innards of the machine. So over here is the Raspberry Pi. Down here is the breakout board connected with a ribbon cable. Over here is the barrel jack for power in. Cable with a little fuse on it. Connects over here to a power switch. Goes up to the PD block. PD block powers the cobbler and the Pi. Some other boards of interest in here. Over here is our 7-segment multiplexer. It uses SPI to drive up to 64 individual LEDs. So you can either do an 8x8 matrix with that, or 8 7-segments with a decimal point. We're using 6 7-segments, so that works perfect for us. And that connects over here up top to these 7 segments. Over here is our load cell amplifier. That one routes up through here to our load cell. It uses a whetstone bridge to amplify the signal and also converts it to digital. From analog, it transmits it using I2C over to the cobbler board. The back of the LCD is going to be up here. That one uses UART to talk to the cobbler board. There's also the calibration switch over here. Connects back down to the cobbler. That will, sorry? Yeah, we'll get the servo. The calibration will allow the user to account for any drift in the readings. If it starts to read over or under, they can put on like precision weights once a month or once a year or whatever and calibrate it. The LCD is tipped up and down with a little servo motor over here, PWM, and that routes back again to the cobbler to interface with it.